In this video, we're going to talk about generics and variable types and object types. And we might answer some questions that you might be wondering about. You might have been wondering about for a while. First of all, we have an object type, and unfortunately, there is a class also named object, which gets a little bit confusing because classes and objects are different things. But there's this class called java.lang.Object, and it is, I'm going to pull it up here. It is considered the superclass of all other classes in Java. So we know that we can set up an extends relationship, as we've seen. I'm going to pull up advanced search activity, for instance. We know we can set up this extends relationship where we have one class which extends another class. In this case, we call this class advanced search activity. We call that a subclass. And the class it is extending, we call a superclass. So that's a superclass subclass activity. Now what's interesting is no matter what you extend, the superclass of everything, the great ancestor, is this thing called java.lang.Object. Now again, it's confusing because this is a class named object when an object, we're confusing the word object, unfortunately. So I call this thing capital O. Let's just refer to this as capital O from now on, because I don't want to confuse the terms of what an object is and the class whose name just happens to be object. So we're going to call this capital O. This is the superclass of all classes in Java. The eventual superclass of all classes is called object. Okay, so what is a variable type and what is an object type? Well, if you look, when we are creating a class, when we are creating an object in a variable, what we'll typically have is a construction like this or a construction like this. We typically declare a variable. In this case, the declaration is to the left of the equal sign. Declaring a variable requires a type, in this case view, and a variable name, in this case v. So declaring a variable, we have a type, which is view, a class called view, and a name, which is v, in this case a variable name. So variables require a type and a name. Now on the right, we're creating a new object, but take a look. We create a new object by invoking the word new, and then we have the object type. Okay, so new, and then the object type, an open and close parenthesis, and a semicolon. So on the left we have a variable type, on the right we have an object type. Notice in this case the variable type is view, the object type is edit text. They're different. Variable type is view, object type is edit text. The variable and the object type are different. Below this we have another example. We have variable type edit text, object type edit text. In this case, they're the same. So what's the rules then? What are the rules? The object type must be the same type of the variable type, or it can be a subclass of the variable type. What do we mean by subclass? It means that the object type must extend the variable type. Not necessarily directly extend, but the variable type has to be somewhere in its ancestry. And why is that? Because the variable type tells us what methods we're allowed to call. Let's look at some examples that we have from our own project. So I'm going to take a look at autocomplete text view here, and you see we have autocomplete text view plant name. Okay. Now if you take a look at this autocomplete text view, watch this. I'm going to say ACT plant name. Now look at the methods that are available. One of the methods is set adapter. Whoops, let me go do that again. Set adapter. Do you see that? Set adapter. Okay. Set adapter is where we are able to set a list of information into an autocomplete text. And as the user types, it will filter that list based on what the user is typing. This is behavior that's specific to the autocomplete text view, set adapter. Okay, we're allowed to call that method, and you see it comes up here Why? Because the ACT plant name is a variable of type autocomplete text view. Okay? The ACT plant name is a variable of type autocomplete text view. Now here's something interesting with Eclipse. I can put my cursor on autocomplete text view, hold Control and press T, and it will show me that autocomplete text view extends edit text, extends text view, extends view, and finally extends capital O. And we'll see that every hierarchy goes like this. The thing at the very top will always be that thing called capital O. But take a look. Autocomplete text view extends edit text, extends text view, extends view. Now, the object type in here is an object of type autocomplete text view. But remember, the variable can either be an autocomplete text view or any of the superclasses that autocomplete text view extends, including view. Watch what happens when I change autocomplete text view. Watch what happens when I change the variable type to simply view. And then we'll save. And I'm going to change this back, but I just want to show. Now take a look. ACT plant name dot set. Our set adapter is gone. Do you see that? We can no longer invoke that set adapter method. We can no longer invoke that set adapter method. So the variable type tells us what methods we're able to call. I'm going to switch this back to autocomplete text view now. Okay, the variable type tells us set adapter, and we see set adapter is back. The variable type tells us what methods we're allowed to call on the variable. The variable type tells us what methods we're allowed to call on the variable. The object type tells us what will happen when we call that method. Now, why does the object type have to be the same type or a subclass type of the variable? If it's the same type, then that's easy, because we know if the object type is the same as the variable type, the object type has all of the methods that are defined in the variable, and therefore everything works fine. Can the object type be a subclass? It can, because a subclass is guaranteed to have all methods of the superclass type. All methods, with one exception, can't have any private methods. It wouldn't have private methods, but that doesn't matter in this case. The object type, if it's a subclass of the variable type, is guaranteed to have at least all of the methods that are in the variable type. It might have more, but it will have at least all of the methods that are in the variable type. And why is that? Because if the object type doesn't specifically declare a method, it will inherit it from the variable type. So object type must be the same type or a subclass type of the variable type. That's a bit confusing, I know. That's a bit confusing, but what we're doing, remember our contract. The variable type tells us what we're able to call. So the object type has to have those methods. The object type has to have those methods. The variable type tells us what we're allowed to call. So the object type has to have those methods. The object and the variable type are allowed to be the same, or the object type, so here we have an example where the same, or the object type can be a subclass of the variable type. Either of those relationships will work. And this is the definition of a word that we use in programming that sounds confusing, and that is polymorphism. Polymorphism means variable type tells us what methods we're able. Variable, very able, tells us what methods we're able to call. Object type tells us what will happen when those methods are called, or in other words, the objective of the method. The objective of the method. So that's polymorphism. Variable tells us what we're able to call. Object tells us what happens when those methods are called. Okay? So that brings up an interesting point then, which is casting. We've seen this before, and it has probably not made a lot of sense. Notice that find view by ID, we have to put the object type to the left of find view by ID, and we have to surround it with parentheses. What would happen if we didn't do that? Let me repeat this line down here. Let me say find view by ID, r.id .act plant name. We're going to make it exactly the same. Now, what does find view by ID return? I'm going to hold Control and press 1, and I'm going to say assign to new local variable. Okay? Find view by ID returns an object of type view. Okay? Let's call this view, we'll call it view plant name. Okay? Now take a look at this. View plant name. Can I call set adapter? I cannot, because the variable is a variable of type view. And remember, the variable type tells us what we're able to call. Variable type tells us what methods we're able to call. So I can fix this if I change it to autocomplete text view. If I change it to autocomplete text view, set adapter, take a look, there we go. As soon as I change that variable type to a more specific type, then I can call set adapter. But here's the challenge. I can call set adapter now, but here's the challenge. I now get a red line here. And this red line says what? Type mismatch, cannot convert from view to autocomplete text view. Well, remember, if I put my mouse on autocomplete text view, we're going to find that autocomplete text view is a subclass of view. That means it has at least as many methods available as view and probably more. It's a more specific type. So to go from a general type to a more specific type, I have to cast. I have to acknowledge that I'm going from a more general type to a more specific type through a cast. It's just something as a programmer that I have to acknowledge. And why do I have to acknowledge that? Because if I'm wrong, I'm going to get a class cast exception. If the types are not the same, I'm going to get a class cast exception, which means I'm trying to convert unequal types, and that will fail. Let's try an experiment here. Autocomplete text view, if I Control T, again, you don't see button anywhere here. You don't see button anywhere here. Okay, look, what if I tried to cast this to a button? Let's watch what happens. I'm going to put button. Okay, I'm going to clean up this last line. We don't really need it. And I'm going to save and Control-Shift-O, organize imports. Oh, you know what? Let me change this to a button as well. Not going to. Well, I'll just change it to a view. That's fine. Save. Okay, and then I'm just going to do int I equals 1 plus 1. I'm going to put a dummy line down there. What I'm going to do now is I'm going to set a breakpoint here, and we're going to run this in the debugger and watch what happens. We're going to run this in the debugger and watch what happens. So it might take a moment for the debugger to rise up, so I'm going to pause this and load the debugger, and we'll watch what happens. One moment, please. Okay, and with the magic of time and recordings, we now have the emulator up. To get to that screen, I need to hit select a plant from the GPS screen. So I hit select a plant, and the next thing we should see is the debugger launch. And sure enough, here goes the debugger. Okay, now watch what happens. I'll resize this. Watch what happens. Okay, super.onCreate, no problem. I'm going to click step over, set content view, no problem. Okay, now the first line is one we've seen before. We're finding this autocomplete text plant name. We're casting it to its proper type, an autocomplete text view. That will execute no problem. This next one will not. We're taking an autocomplete text and trying to cast it to an unlike type, which is a button. That will definitely fail. It will throw a class cast exception, and we'll see that our application has closed, or our application will close. You'll notice we probably won't even get to line 32. We'll throw an exception instead. So I step over. Line 32 we never see. We go right here. We see that we have some interesting text. And if I step maybe a couple more times, we should see right here class cast exception. Class cast exception. That means we're trying to cast one object type to a type that's unrelated. In this case, an autocomplete text to a button. Okay, an autocomplete text to a button. Now what I'll do next is press play, and you'll see the Android emulator will tell us there's a problem, and the application unexpectedly closed. Oh, okay. Well, it actually went back to plain places, but nonetheless, what it would normally show there is that the application unexpectedly closed. In that case, it looks like I had it debugged when that message came up and we didn't see the message. But that's what a class cast exception is. Okay, so the casting's ugly. Casting's ugly because it can cause a, oh, okay, there we go. There's the message finally. Okay, there's the message. I just saw it come up. Yeah, and that's the error that we just forced to happen. So that's what your user's going to see. Obviously, that's a quality issue that we want to avoid. Okay, it's a quality issue that we want to avoid. So casting is ugly because first of all, we have to understand what this cast is. Secondly, we have to understand that we can have these ugly class cast exceptions, which will cause our program to terminate unexpectedly. So casting seems kind of random. So far, we've been casting our find view by IDs, and we haven't really explained why. And by the way, before I forget, I'm going to go ahead and clean this up. We've been casting our find view by IDs, and we've never actually explained why. So it's ugly, and it can lead to runtime exceptions, and we never want a runtime exception. So how do we handle this in a more glamorous way? Well, around Java 1.5, we got something called generics. And what generics allow us to do is specify a type at runtime. It allows us to specify a type at run. Well, actually, we specify the type at compile time. It gets used at runtime. So it turns what would have been a runtime class cast exception into a compile time error that we can easily fix at compile time. And once we've fixed it, we no longer have to worry about it. We've been using generics all along. You see this thing called new array list plant. And I know we've used that. Let's see, if we look in our plant results activity, I'm sure we'll see one of those here. Okay. Right here, array list plant, all plants equals new array list plant. In this case, at compile time, we're specifying a type. Okay, we're specifying a type. And what's nice then is if I were to try to retrieve something from this array list, let's say I said all plants is the array list, and we'll say get, and I'll say maybe 1. Okay, take a look at this. If I control 1 and say assign to new local variable, it knows that array list contains a plant, because when it creates the local variable, it creates it as a variable of type plant. It creates that local variable as a variable of type plant. If I were to change this into something else, like a button, watch this. It's going to give me a compile time error. Let me change it to something else. Let me change it to, I don't think I have a button, or do I? I can make a button. I can Control-Shift-O. Okay. You see what's going to happen here is it tells me there's a type mismatch. So that's what generics are doing for us in an array. And again, I'm going to clean this up. But that's what generics are doing for us in an array list. We specify the type once, and from then on, anytime we refer to this array list, we get to use that type. Okay, and if we don't use that type, the compiler will warn us. So generics allow us to specify a type at compile time and thus prevent a runtime error from happening. Okay, we'll see when we look at async task, we'll see that generics allow us to do something else which is very interesting that we haven't explored yet. It allows us to override a method. When we extend a class, we can override methods from the superclass. It allows us to override that method, and it allows us to determine the return type and the parameter types of that method when it's overridden. Okay, that sounds tricky. Let's wait till we have a hands-on example. We'll explain that more. Okay, so why generics? Flexibility. Looks like I misspelled that. Why generics? Strong typing allows us to avoid casting. We know we don't like casting. It's ugly and error prone. It's not user friendly. it seems kind of random that we invoke find view by ID and then we cast to edit text. So that's one benefit of generics. But with generics, they give us strong typing, but with some flexibility. So we can specify the type when we use a class. So array list, plant, we're specifying that this array list will hold plants. Okay. Um, Again, I know this is a fairly technical conversation talking about polymorphism, variable type, and object types. So I wouldn't expect you to completely understand everything, but I did want to give at least a little bit of a preview before we get to async task, because async task uses generics like this, and it helps to know a little bit about why we have generics, so we can avoid class cast exceptions, so that we can have strong typing, but we can have flexibility as well. We can have strong typing that avoids those class cast exceptions, and we can have flexibility to specify those types later on. We don't have to specify them when we make a class. Again, I know that sounds a little bit confusing. So I'll encourage you, if you're watching this video, I'll encourage you to watch the async task video while this video is still fresh. The async task video will be our next video, and that's going to have some hands-on examples of what these generics are and how we can use them. Okay, so generics, we know that generics allow us to avoid casting. We know capital O is the grand superclass, the ancestor of all other classes that we have. We know that polymorphism tells us, variable type tells us what methods we're able to call, object type tells us what will happen when we call those methods. And we know that an object type can either be the same as the variable type or can be a subclass of the variable type. Those are the rules. Variable type is what's on the left of the equal sign. Object type is on the right, often following the word new. So a quick review of our lesson for today. Again, the next thing up is to look at async task. Thank you.